Hi everyone, it's Mrs. Page, and I am here today to take you through another engineering design challenge. And this one is how to build a catapult. The first step in the engineering design process is going to be to ask our question. And that question for today is, how can I build a catapult that flings an object with accuracy? So for this challenge, we have a few criteria and a few constraints, just like any good engineering challenge does. For our criteria, we want to be able to build a catapult. It must be able to hold an object and fling an object, okay? And it has to hit a target in order to be accurate and score points. As far as our constraints or things that we need to take into consideration, um, we're only using the materials that we have at home. So you can build and design your catapult any way that you would like, but you are required to use materials that are already in your home, kind of like recycled materials. You can only use a soft object for your launches, so no launching golf balls or marbles because that can be dangerous, especially if your catapult works really well. So you want to make sure that you have a soft object that you can use for your launches. I am going to use kind of like a little plastic golf ball. You might have something you can use, even like a grape or a blueberry. You can use a little like ping pong ball or a foam, like a small foam ball if you have one of those. And then our launching distance is going to be 3 feet from our target. So the next step, after we know what our design challenge is, we know what we're trying to build, we're going to start to imagine, and we're going to start to generate ideas or come up with what we want to our catapult to look like, and how are we going to build it, what materials are we going to need, and then how are we going to put our parts together. So for my catapult, I think I'm just going to try and make like a pretty simple catapult that is going to be made of popsicle sticks, because I have popsicle sticks at home, and I know popsicle sticks are a little bit flexible. So I'll be able to get the tension force that I need to fling an object. I am going to use some sort of object to put in between my popsicle sticks so that it creates like it serves as like a wedge, and that way it lifts this other popsicle stick up so that it has the ability to be kind of forced down, creating that tension that's going to turn our stored up energy, our potential energy, and our object into kinetic energy. It's going to set that object into motion. I think I'm going to try a spoon for a holder. Something else I thought of is like you could cut the bottom off of a plastic cup, or if you have like a plastic coffee lid, maybe from someone's cup of coffee, you could attach that to your catapult. That could be a holder. You just need something that's going to hold your object in place while it's still, so that it can fling it, right? So I think I'm going to use a bottle cap right now for my first design in between my popsicle sticks. I'm going to attach my popsicle sticks with elastics because those have the right properties, right? They're flexible. I can wrap it around a bunch of times, and it'll still be a little flexible. And the other things that I might need are, I might need some tape, right, to attach my spoon or whatever I use for my holder to my popsicle stick. Okay, so that is what I'm imagining my catapult to be like. I'm going to start to really create my plan, right? I know what my materials are already. I need popsicle sticks, I need elastics, I need tape, I need a spoon, and I need my wedge. I'm going to start out using a bottle cap. I'm going to go and I'm going to gather my materials up. I'm going to build my catapult, and then I am going to test it. And as part of my plan, I've already set up my test area, which is right behind me. So I will show that to you and explain how you can set up your own at home too, to test your design. So I will be right back. I'm going to go gather my materials, and then we will start our create step, where we're actually going to use our diagram from our imagine step and our materials to create our catapult. All right, boys and girls, I am back. I have my materials, so I am going to use 3 popsicle sticks. If you don't have popsicle sticks, you could try using, if you have other small pieces of thin, flexible wood, like paint stirrers, so they're like long, thin wooden sticks that you use to stir paint. You could try those. If you have, they're called like little bamboo skewers, meat skewers, you might be able to join a couple of those together. Just be careful that with if they have sharp ends on them. And be creative. I mean, you can make a catapult with really anything that has a little bit of flexibility to it. And by flexibility, I mean it has the ability to bend, right? But it's still somewhat rigid so that you can get that flinging effect. Right? And you can also look up ideas for catapults online, right? So the internet is a great resource to see what other people have done, and then you kind of adapt their ideas to be something that that you make it into, right? So I have my popsicle sticks and I have an elastic. So the first thing I'm going to do, and I'm using 3 popsicle sticks, 2 to make my base a little bit more steady and rigid, and then the third one, which is going to be my actual mechanism for flinging my object, right? My launches. So I'm just going to wrap the elastics around the bottom of the popsicle sticks. What's important here is that I can kind of lift them up a little bit and create that tension that I need to be able to set my object into motion. So I am going to then, I took my tape and I taped the straw, I taped my spoon right around my top popsicle stick. Okay, so I taped it there. Now, I taped it for my first design. I taped it about halfway down. You can see how much my spoon is sticking out, and that's gonna, again, a spoon is a little bit flexible, but it's still somewhat rigid, so it gives me the ability to put that tension on it, right? So then I need my wedge, and I'm gonna use, for my first version of my catapult design, I'm gonna use a bottle cap, which is pretty small, but it's going to give me a nice angle, right? And I want this to angle up so that it has an even higher ability for, right? It's kind of like what a spring does, right? When you hold it down, it has a bunch of tension in it, and then when you let it go, it releases all that stored up potential energy. It turns it into kinetic energy and sets things in motion, okay? So this is going to be my first catapult design, right? So I have created my design, and the next thing I'm going to do, the next step in our design process, is to test. Now, to test your catapult design, remember you're going to be testing it from 3 feet away from your target. So the way that I made my target is I just have 3 different size bowls. I have one in the front, that's the biggest bowl, and then touching right behind it, I have a second bowl. Sorry, let me show you there. And then I have a third smaller bowl behind that. So for my target, and you can make your target however you want, I use 3 different size bowls, because the larger bowl, if I get it in there, is going to be worth the larger bowl is actually going to be worth the least amount of points, 5 points, right? Because that would be the easiest bowl to get it in. The middle bowl is going to be worth 10 points, and then the smallest bowl is going to be worth 15 points, because that's really going to be hard to get that into. Okay, so I set up my target. Now, if you don't have 3 bowls that you can use, I mean, you could create a little like targets out of paper. You could use cardboard and make little rings, right? Kind of like if you've ever played skee ball, where you throw the ball up a ramp and you have to get it into the circles, the different size circles. So you can make a little target out of cardboard too. One of the criteria for our challenge was that our target is 3 feet away from our launch spot. So you'll see that I took a tape measure, and you can estimate too if you don't have a tape measure or ruler, and I marked off on my carpet with some painter's tape. I marked off 3 feet. So that is where I'm going to be doing my launches from. And when you do your launches, right, because we're trying to hit a target that's a little bit raised up, we're actually going to be holding our catapult in front of us, right? So we're going to be holding our catapult in front of us, and it's going to allow us to get a little bit of an angle on it so that hopefully our ball will go into our target, but I don't know if it's going to. So we're going to have to test it out, right? So that's how you set up your test space. And then if you are going to record your data, which I am going to record my data, I just made a little recording sheet where I'm going to be able to do 8 trials with my first design. So you can do anywhere from 5 to 10 trials. I'm going to do 8 because that's how many fit on my paper. And I am going to tally up the total amount of points that I get from all 8 of my trials. So there's a couple ways that you can analyze your data and kind of look at it to determine how successful your catapult was. And you can also kind of make it into a game if you wanted to do this with somebody else at home, right? And have kind of like a challenge with them. So I'm going to start my trials. I'm going to do a couple of trials for you. We'll see if we have any success getting it into the bowls or the target, right? So I have my object that I am going to fling. And again, it's kind of like a ping pong ball. It's like a little plastic golf ball. And I'm going to be 3 feet back. I'm holding my catapult up at kind of that same distance, straight from my bowls. And I'm going to try it. Oh, it bounced out of that bowl. If you wanted to, you could technically, I think, count that as points because this is your design challenge. But I'm not going to count that as points because I want it to actually land in the bowl. Okay, so I'm going to try it again, and this time I'm going to put a little less force into it, and maybe I'm going to hold it a little bit lower so that it doesn't hit with such an arc and bounce out. Oh, and that one was just a little bit short. So I can tell that the adjustments that I made, right, I noticed what caused my failure, and the adjustments that I made, it were effective. It was just a little bit too short. All right, so I'm going to keep trying. And that would be 3. And so far, I haven't gotten any points, right? So if you wanted to do more than 8 trials, of course, you could. Okay. Oh, yes, that went in, right? So it just got into that first bucket, which is the easiest one. It's the biggest, it's the closest, but it bounced and went right in. So I will consider that a success. Okay, and then you can do more of your trials, and you want to record your data. So I'm going to finish my trials and record my data. And once you record your data, right, and you can kind of take a look at your data and you can analyze it in a couple different ways. So when I'm looking at my data, I did get mostly zeros, which is, not really surprising for me because it is really hard to be accurate, especially when you're not in control of the object that's being flung, right? Your catapult is kind of doing the job for you. So I did get a couple of 5s, and I did get one 10. It actually bounced out of the 5 and went into the 10, so I'll take that. When I look at my data, I can say, well, the highest score I got was a 10, and I got 2 5s, but mostly zeros. So you could average your data by adding up all of your data points, right? So I have 8 points of data. I could add these all up, and when I add them, it equals 20, right? 5 is 10, plus another 10 is 20. And then to find my average, I would take all the digits that I added, which came to 20 points, and I would divide by 8 because that's how many numbers I added. So 20 divided by 8 would give me my average score, which isn't very good. It's somewhere between 2 and 3, right? About 2.5 points per trial. Okay, so you could look at your success score as what is your average score from your trials. You could also, if you wanted to do it more like a contest, if you were playing with somebody else at home, you could say, well, who got the most points, right? So for my first design, I got 20 points. Maybe your sibling creates a catapult and for their first 8 tests, they got 15 points. So you would be the victor there, right? The winner. So there's a couple different ways you can kind of look at your data. You can do it by yourself and find your average. You can do it with somebody else. You can make it into like a contest, right? Because this is supposed to be fun and it's your design challenge. Okay? So after we do our original design and our tests, we're going to take a look at the next step in the engineering design process, which is to improve, right? So we always have room for improvements, and we take a look at what worked well for us in our catapult, and we determine what we might want to change, right, based on what our failure points were. So we're going to do a little redesign, and then we will retest and gather some more data on our new design, right? So there were a couple things when I was doing my tests that I noticed, right? I was wondering if I had a bigger object in the middle here, would that give me some more spring, as in like, would I be able to put a little bit more like flexible tension on the end of my object, and maybe that would be able to give me like a more accurate launch. So I got, this is just a cork, and it's going to give me a bigger angle here. So I'm wondering, I'm just thinking, like, would that give me a little bit more, see it has a little bit more spring almost, a little bit more kinetic energy will be formed there if I use a wider wedge, right, a bigger wedge. So I'm going to try that. Something else I also thought of is like your, is my spoon, and I'm wondering like if I shift it up or down on my popsicle stick, would that make a difference in the accuracy? So for my redesign, I am gonna, there's less spring when I move it down. If I move it up a little bit, feels like it might be a little less controlled. So I'm gonna try moving it down just a smidge. Can still get some good spring on there. Okay, so I moved it down just a smidge, and those are the two changes that I'm going to make for my retest. Okay, so now we're going to retest our catapult. Okay, and I'm going to use the same launcher, and I'm going to go the same distance, 3 feet away from my target, and going to do the same type. The same type of launch, right? I have to find the right spot. I think it was about here where I flung it from last time. Ooh, that went pretty far. That had a pretty high arc, so I might have to use a little less force when I launch, because that went way over my bowls, right? I want it to go in that back bowl, but I don't want it to go too far. That one didn't have enough, so I need to find somewhere in the middle, right, for my third trial. Ooh, and that was a little off to the left, so I'm going to maybe make sure that I move my catapult so that it is directly in front of my bowls. Oh, so close to 5 points. And you can keep on testing it. Again, you can do, oh, that was really close to 15. You can do more than 8 tests if you want, and you can do as many as you want. You can make it like a game, right? All right, so no success so far, but I am going to continue to do my trials, and then we'll look at. All right, so I did some more trials, and this time I was only able to get it in the bowl, one of the bowls twice. The big bowl at the front, again, it bounced in front of it and then went into that 5-pointer. And then my very last trial, it went right into that last bowl for the 15. So I had a total of 20 points, pretty much the same as my first design. The thing I did notice was that my first design I had 3 in the bowl, and on my second design I only had 2. So I could say that my first design was maybe a little bit more accurate, right? Because I got it in more times. And if I wanted to really test it, I could do more trials to support that conclusion. Okay, so the last step of the engineering design process is to share the results. And I was kind of doing that as I was talking about my data, but something that I wanted to point out to you is that when you build a catapult, right, it's important that you understand that you are taking an object, right, that has this stored up energy, potential energy in it. You're creating a device that's going to change that potential energy in your object in your catapult into kinetic energy, which is energy in motion. So a catapult is designed to help people do the job of moving objects, maybe flinging them far distances. And when you use a catapult, you see a shift from potential energy to kinetic energy. And that shift is created when you apply force, in this case, tension, to your catapult. Okay. So I hope you enjoyed our engineering design challenge, and I really hope that you try it out at home. And if you do get a chance to try it out and your parent says it's okay, you could share a video or a picture of it on our Facebook page, or you can email me a video or a picture of your catapult design or your data table. My email is erinpage@bpsma.org, and I would love to see your catapult designs. Happy engineering!